In this lesson, we are going to look at how to use the Cramer's rule to solve systems of equations into two variables. Now we're looking at linear equations. So let's look at the first example. So we have two systems of equations. The first equation is 2x plus y is equal to 7. The other equation is x plus 3 y is equal to 11. So our first step is we need to turn the given two equations into a matrix. So the way the matrix should be written is we need to have a matrix like this one. We just consider it as matrix A. Then the coefficients of x should be written on the first row. So this is where the coefficient of x should be written. Then the coefficients of y should be written on the second row. So our y should be written here. Okay, now let's look at the actual example. So matrix A is equal to, okay, so we can look at the first coefficient of x is 2, will be written here. Then the second coefficient of x, the number in front of x, this one is just 1. Then the second one we look at now, the coefficient of y is 1. Then the other coefficient of y is 3. So that is our first step. Then from there we are going to find the determinant. So we just look at this as the determinant, the general determinant of A. So we need to multiply 2 multiplied by 3 minus 1 times 1. From there, d is equal to 2 times 3 is 6 minus 1 times 1 is 1. d is equal to 5. So our determinant is 5. Now, after finding the determinant of the general matrix that you have formed, you need to now find the determinant denoted by letter x. Then the same determinant is the one we are going to use to find the first actual answer, the value of x. Then number 2, we are going to look at the value of y. So now let's make another new matrix. Now, it depends on the one that you want to begin with. So if you are finding the value of x, the first column here, the first column, like here, the first column must be substituted with these two numbers, 7 and 11. So let's solve for x. So here we put 7, then here we have 11, then the other column will remain like that, 1 and 3. Then from there, we can now find the new determinant, but this determinant will put x here, denoting that we are finding the one that will give us the value of x. So we can say that it's 7 times 3 minus 11 times 1. 7 times 3 is 21 of minus 11 times 1, that is 11. 21 minus 11 is 10. Then we can now find the value of x. So x is found by the d with the x on top over the determinant of the original matrix, this one. So we can now proceed. The determinant of x is 10, the one we have calculated here, over the first determinant, 5. 5 into 10 is 2. So the value of x is 2. Now let's solve for the value of y. Now for the value of y, this is where we are going to replace with these two numbers. Then the first column will remain the same. So 2 and 1 from the original matrix, this one. Then here we are going to have 7 and 11. So let's find dy. So this is 2 multiplied by 11 minus 1 times 7. 2 times 11 is 22 minus 1 times 7 is 7. 22 minus 7 is 15. Now to find the value of y, so y is equal to determinant of y over original determinant. So determinant of y is this one, 15, over the original determinant, 5. So 5 into 15 is 3. So this is how you can find the values of x and y using the Cramer's rule. Let's have another example. Okay, so now this time we have this matrix, two equations, 5x plus 7y is equal to 44. Then x plus 3y is equal to 12. Now you are feel free to pause the video and give it a try. Now let's begin. Let's first find the matrix. So we can just say matrix A is equal to, so the coefficient of x, this should be written on top. So the first coefficient of x is 5, the other one is 1. Then the coefficients of y should be written on the bottom part, on the second row. So here we have 7 and 3. Now let's find the determinant of this particular matrix. So it's 5 multiplied by 3 minus 7 times 1. 5 times 3, this is 15, minus 7 times 1 is 7. 15 minus 7 is 8. Okay, now let's find the determinant of the x value. So we said we are going to replace the first column with these values in order to find the determinant of x. So 44 will be here. Then the other column will remain like that, so 1 and 3. So let's find the determinant of x. So this is 44 multiplied by 3 minus 12 times 1. So 44 times 3 is 132. Minus 12 times 1 is 12. 132 minus 12 is 120. So now the value of x is equal to d of x over d. So this 120 over 8. 8 into 120 is that is 15. So the first value of x is 15. Then let's look at for the value of y. Now for the value of y, we are going to replace the second column with 44. So 44 and 12 will be here. Then the first column will just remain the way it is. So let's find the dy. So 5 times 12 minus 7 times 44. 5 times 12 is 60 minus 7 times 44, that is 308. Then 60 minus 308 is negative 248. So to find now the value of y is equal to determinant of y over original determinant. So negative 248 over 8. So our final answer is negative 31. So here we have negative 31. So that is it. So as you can see, it's simple and direct. So this is how you can find the solutions for linear equations using Cramer's rule on matrices. That's it for this video. Thanks for watching.